Dialogue and Cocktails, live from Austin, Texas, as well as someplace else. You'll find out in a second. We're a honest, no BS, non-salesy conversation about enterprise data management, and we have tasty beverages in hand. I'm Tim Gasper, longtime data nerd and product guy at Data.World, joined by Juan.
Hey, Tim, I'm Juan Cicada. I'm principal scientist at Data.World, and I am joining you all live from Lyon, France. So it is 11 p.m., so I'm actually really enjoying my cocktail right now. I'm here. We're organizing the web conference, which is the largest scientific conference for web research, which is a sneak peek. It's going to be in Austin, Texas next year, which we're hosting it. So really excited about that. But let's go talk on some other things today besides the web. We get to listen to everybody thanks to the web. The web is one of the most marvelous things that have been created. So we're very thankful for the web.
Some useful tech there.
A useful tech for sure, yeah. Well, today we're going to have a conversation, which I think is something that is getting hotter and hotter. I'm hearing it more and more. It is about semantic layers and metrics layers. And I think the person who is really driving a lot of this stuff right now is Nick Handel, who's the CEO of Transform. Nick, how are you doing?
Welcome.
Hey, it's great to be on the show.
Awesome.
Thanks for inviting me.
Yeah, no, I think
I wish I had a good radio personality. Like, hey, it's Nick. I love your character.
Gotta have your
that you guys jump into at the beginning of this.
Character mode, but well, the funny thing is that I've been following Nick for so long now during the pandemic, right? Everybody on social media, but we were at the Data Council, and we've talked before, like we've had Zoom meetings and stuff, and then literally we sat down and I'm like, oh, I'm sitting next to Nick. Finally, we get the chance to talk. So that was a great random moment at a dinner we had.
Yeah.
All right. What are we drinking? What are we toasting for?
All right. I have this cocktail mix called House. I don't know. It's somebody sent it to me. House.
Oh.
And it's made in Sonoma. But this is a bitter clove mix. And it's 2:00 in San Francisco. So mixed it with some sparkly water. And what am I toasting to? Let's see. I got engaged like 2.5 weeks ago. So I'm definitely toasting to that personally. Thanks. And then professionally, we released a big open source project as a company, and that's like, I don't know, it's fun to put yourself out there. So metric flow is new, and we'll get to talk about that. So
wow, that's awesome. And I guess I think I emailed this to you, but you transformed your life, so congratulations.
I really did. Yeah.
And also
big transformation.
You should all, Toasta, you guys had your summit yesterday, right? So
Yep. We had a metric store summit, and a bunch of different presentations. That was kind of our first big event as a company. We've done kind of smaller things. So another, we're starting to put ourselves out there in more significant ways, which is really fun.
Hey, Tim, what about you? What are you drinking, toasting today?
Well, great question. Well, first of all, that's very exciting, Nick. New chapter personally and new chapter professionally with the company. So that's really exciting.
Yeah, totally.
So what am I drinking? Well, you know what? I recently picked up a new kind of gin. It's this Hendrix Lunar. And it's pretty interesting. As I'm not a super big gin person, but it has a very like an herbal and almost like a floral kind of taste to it. Mixed it with a little bit of ginger ale and some lemon. It tastes pretty good. So that's what I'm drinking right now. What am I cheersing to? You know what? I don't have anything as exciting as what you said, Nick. So I'm just happy to be here talking about data. I'm cheersing to data and conversations.
I love that.
Well, what about you, I'm having a Hendrix gin and tonic right now.
Oh, you got Hendrix too? Oh my gosh. Yeah, like an advertisement for Hendrix right now.
Oh wow. Yeah. And I'm gonna cheers for Nick for getting engaged. And hey, I'm in Lyon. I can't complain. This is the culinary capital of France, and we're here to go celebrate the web research. And I'm also very thankful for the web for everything that has given to us. So cheers, everyone. Cheers. All right, so we got our warm-up question today, which is cake, dip, or sandwich, what is the best layered food?
Okay, so you told me I could go, I could go rogue here a little bit. And I'm gonna go eggplant parm. You get some
Ooh.
layers in there, some like nice melty cheese, some tomato sauce, some eggplant. Um, yeah, it's like
Oh
one of my
man,
favorite dishes.
I
How
do
about
like
you?
eggplant parm. Now
Good.
you're opening up all sorts of
Yeah, you
possibilities.
Yeah,
cooked it up.
Now I kind of want to be
break
like,
the
well,
box.
pizza has layers, right?
It does. It does for
I
sure.
was gonna say cake because I don't know, dip and sandwich. I don't really think of those as layered foods, but I don't know. What about you, Juan?
Well, I was gonna say a burger, like a cheeseburger, make it layers, but now you're like, oh,
Nice.
then it's lasagna. I think for me with all those layers, but
So we were
uh,
supposed to choose between cake, dip, and sandwich. We ended up with pizza and egg parm, and
the
And
burger
lasagna.
and
for the creative
lasagna.
bunch here.
All right, well, let's kick this off. So, all right, Nick, simple, honest, no BS. What is your definition of a semantic layer and a metrics layer?
Okay, so I gave a bit of a talk on this yesterday, so I'm, prepared for
French.
this, but I kind of build it up. And so, starting with a semantic layer, um, a semantic layer is basically if you think about like the tables that are underneath the semantic layer, right? It's kind of a way of like representing a bunch of data that's in the warehouse. And so basically what we're doing is we're mapping various tables to classes, right? So I've got customers, I've got products, I've got transactions, and then we're mapping the various kind of rows of those tables to individual instances of those objects, right? And then we're mapping the columns to kind of various measures and dimensions, which are attributes of those objects, right? So we're basically saying we've got tables, they are classes of objects. We've got different instances of those objects, and they have various attributes. And then we can do a bunch of really cool stuff with that, right? We can like define relationships and do joins and all of that kind of stuff. Like this is not new. Semantic layers have been around for a long, long time. We've got an expert on the panel here, so we can go deep there. But there is this kind of like fundamental problem with semantic layers, and that's kind of twofold. One is that the abstractions are fairly kind of low level and granular and tied to this kind of table object, right? And so basically, the way that I define a metrics layer is something where you're ultimately trying to define metrics, right? You're trying to define, ideally in some reusable way, the definitions of various metrics that your business cares about. And so one of the ways that you could do that, I think that there are semantic lists, kind of definition structures that you could go and just freely write SQL to define metrics, etc. It's very common to do that. But if you have a nice semantic layer, then you can basically take those various different tables. You can kind of imagine like the entity relationship diagram of these various tables and how they connect to each other. And you could go and define metrics on top of the various kind of classes, the different objects, and the different attributes. So, if you have two events, you could go and define a conversion event, which would be, event A, event B, join these two things together, take two timestamps from each of them and say that they have to happen within some window of time of each other, right? And so ultimately, there is this semantic structure that's underneath, and we are just defining metrics on top of that semantic structure. And that's kind of how it extends beyond the traditional concepts of measures, dimensions, and relationships that traditional semantic layers have.
So what does life feel like before the semantic and the metrics layer? And then what does life feel like with the semantics and the metrics layer?
Yeah. So before, you've basically got, a ton of SQL. Like you've got all of your different raw tables that come into your data warehouse. You've got, a bunch of different kind of SQL that is going to go into the process of kind of normalizing those tables, cleaning them up, making them consistent, like making all your country fields match each other, making them nice and clean and easy to consume. That process is like fairly containable, right? Because it's kind of linear. You go from like, a raw table to a normalized table, you're defining the same kinds of transformations to get to those clean representations of the data. From that point on, you just have this like explosion of potential, opportunities of things that you can do with that data, right? You can join lots of those data sets to each other. You can traverse multiple data sets to join various data sets together. You can aggregate them in all different kinds of ways. You can apply all kinds of filters. And ultimately, what that becomes is kind of like the way that most companies have their DAGs organized is just a ton of data transformation from those normalized tables to build various data marts for different applications. And when a company is small, that feels manageable by a small group of people. When a company gets really big, it quickly grows unmanageable. And so the kind of pain that people feel and the reason why they want to, define their semantic structures at this kind of more granular level is that they don't want to basically manage all of that logic manually. They want to define it in one place, and then they want to kind of programmatically consume in different, applications. And that's kind of traditionally like the reason why people have adopted semantic layers in general. But I think that the extension of the metrics layer, like what having that metric object does, is it actually creates a full connection to the way that the end business user talks about data, right? Like the end consumer of data, when they go to a data person, they're going to be like, hey, I need revenue by day by this, new product category I just launched. And the data person is going to ultimately take that, compile it down in their brain into a SQL query and then express that SQL query and run it against the warehouse. But that compilation layer can basically be done programmatically. We can kind of remove the need for the data analyst to have to be that compilation layer.
Mm-hmm.
So let me go replay this, what you've said, put it in my words, and also kind of align it or match it with kind of situations that I've been. I think so. Before, what we have is you get all this data dumped into your lake or whatever. Okay, so let's assume it's all queryable in one place, but it's all just a dump. You move you did E and the L, right? So it's all in one place. And now what happens is that users, data consumers, analysts, people need to go answer a question with respect to some metric. How many events are occurring, or these types of questions? They're like, okay, go, the data's in the lake, go figure it out. So they will do all this work, which is going to be either I created this gigantic SQL query that generated the table that now I can use that table to go answer my question. Or I'm splitting that up in so many different pieces, and then I generated this thing here first and this other thing because I needed this data from this other thing. Right? So, and that's where you're calling these the DAGs, right? So there's your data is moving so many places, and then I finally got the data. Sometimes that all work may happen inside of your data lake. That sometimes that may all be done in your analytics tool in a Tableau. Maybe it's split up, right? So at the end, you have all this logic, which could be this gigantic SQL query or a SQL query that's over the warehouse, another part over the analytics in the analytics tool. I mean, at the end of the day, people are solving the problem of I need to answer my question, but the process to go do that, frankly, if you're in a small organization, it's okay. But the moment you grow or you keep growing, you have all this turns into some legacy debt. Let me stop there. Are we aligned?
I think we are. I think the one thing I would add there is just at the small organization, people are building that legacy debt before they know it.
Bingo.
Right?
Love that. Agree. Yes.
All right.
Okay. So we're in agreement. Okay.
We're aligned.
Okay. So now, so that's the before. Now let's go talk about how we would actually be implementing here a semantic layer. And let's not even call it vendors or anything. Let's like just what does it look like? So all my data is still in this lake. I got all that stuff in there. Now, what you really want is to not say, oh, I need to go generate data to be able to go answer these questions about the real active users or something. No. How about let's think about what are the core concepts that are needed for that metric, which is, I need to know what a user is and what is an activity. So then we start thinking about, okay, the concept of a user, the concept of an activity. And then we so what does a user mean? Well, the user in this case is going to be physically represented as a table, and we need to have the user ID, the username, and some characteristics about the users, which those are going to be columns, right, inside of the table. And now
Yep.
that's basically, I have a very clean, normalized table. That table represents the concept of a user. Now I need to take all that data that's in my lake and transform it to fit that particular very simple table of a user. And then I would do that same thing for the activity, right? Whatever activity is, do the exact same thing. And but in this case, I need to know, well, activity is related to a user. So I also need to know what is the primary key or the foreign key, whatever, to go point to that user. And I do that. So at that stage, what I've really done is you take all the data that's in the raw source data. I've defined a target schema, and that the target schema reflects the real world concepts. And then this transform is this mapping, whatever, could be one query, could be multiple queries, whatever. But at the end of the day, it's going to be populating that target tables. In this case, in this example, it's a table called user and a table called activity. All right, I said a lot. Let me pause.
Yep. Yeah, I mean, basically what I'm hearing is like, we talk about ELT, but the reality is we're kind of doing like ELTTT. Like there are kind of three different T's. There's like the normalization T. There's this like denormalization that's happening in the warehouse. And then there's this further denormalization that's happening in downstream applications, right? Like, okay, now that I have this nice data mart, let me go to my BI tool and, run a query against that data mart and do further aggregation, further filtering, further, et cetera, in order to get myself down to that actual unit that is consumable, which is oftentimes just a metric. But now I'm managing logic that I have, scheduled in my DAG and logic that is in the BI tool in two different places. And I'm trying to maintain consistency. And I have, a huge number of tables, different data marts that I've built for different applications because I need to kind of boil the data down into small consumable things. And now I've just got like logic spread everywhere. I'm trying to figure out, how aggregated is this data? How filtered is it? Like, am I answering the right question? And I think that is the problem that, a lot of people experience.
So I really like what you just said. The problem is we're doing ELT, and managing all these TTCs is the problem.
Yep, exactly.
That is very insightful how you just described that. I think that's a very clear way of defining what's going on. And I think I think if we say having so many of these T's, that's hard to manage. And that's
it's
just
the
more
depth.
Debt. It's a debt. That's very, very insightful like that. But then going back to the process I was telling you, I mean, is this how you would see the process of creating that semantic layer to be?
Yeah. So, I mean, I think that the purpose of the semantic layer is, well, first, there's a bunch of things that enables, and, we can dive deeper on that. Like, frankly, I don't think that self-serve is possible without a semantic layer, right? Like, you need to map concepts that are technical to concepts that are like human understandable in order to create a tool that humans can interact with without having technical context of the data, right? That's just like, there is like truth there. There's no way around that. And so there are a bunch of reasons why semantic layers are really powerful and why we should be talking more about them. But I think that, sorry, what was where were we going with that?
No, I described this process at the end of the day. I just want to understand that I want to make sure that we're on the same page, or I want to know on the process to create the semantic layer, because at the end of the day, it doesn't seem that complicated. I mean, if we actually do things very, very nicely, if we have everything in one snowflake instance, for example,
keep it simple.
All my semantic layer is a bunch of views that I'm defining, and then I just generate the every table that represents a concept. That's the semantic layer, and that's it. And then I have a bunch of views which generates all my transforms, my mappings.
Right. And so, okay, so if you think about like what information your business has, right? If you have a bunch of different data sources, like what is the definition of normalization? It's not duplicating data, and it's consistency of like different objects, right? So if you have a country attribute, then it's defined the same way across a bunch of different tables. Like if you have a user country and a store country and a bunch of other stuff, like you don't have US and United States and like USA and a bunch of different places. You just have US, and every column is the same everywhere. So that's what normalization is, right? Once you have that, if you have all of your data in that format, then you define semantics on top of it. Everything else downstream of that is boilerplate code. Like, it is a ton of boilerplate code that is basically getting expressed repeatedly around an organization. That's the value of a semantic layer. I think we agree on that.
Yes, that we agree. So let me go quickly on the next thing is I'm already I'm backchanneling with Tim. He has a bunch of questions I know to do, but at the end of the day, and this actually was a conversation we had with Chad Sanderson, I think our 1 or 2 episodes ago, is if you have a successful semantic layer, when you define your metrics, it should be very simple to go define that metric. And I'm literally saying it's a couple lines of SQL.
I would love that to be true, but I don't quite believe it. And here's my thought about that. That I think is the dream. Like, that is the vision. That would be wonderful if we could get there, right? If I could basically understand the relationships between different data sets, the intentions of people when they're actually building their models, right? And maybe we can, work up to this, but I don't know, like, if, somebody has like an SCD table and they've got this column, defined in this other table, like, if the data is truly perfectly clean, maybe you could do that. But the reality is like, if I have a metric, if I have revenue and I have, product category, and that is in a product table, right? I need to know the join relationship between the transactions table where I'm generating the revenue metric and the product table that has that product category. And I could try and guess, I could do my best, but there's a ton of logic in there. And like, the person who's actually modeling the data knows that. And so they need to give that logic to the semantic layer in some structured way. And maybe they could express this in SQL, like maybe they could write out that SQL for that thing. But ultimately, what that semantic layer would do is it would take that SQL, it would decompose it into the various transformations, and then try and turn it into a structured format where it could then go and generate the end SQL that would be needed to kind of ask for that same metric by a bunch of different dimensions, right? And so you'd be expressing this logic in a very unstructured way, and then expecting it to be compiled down into a very structured format for you to then go and ask different questions.
Interesting. Okay. I think we're gonna come back to the technology, I think, some more, and dive into and dissect this even a little bit more about how this is put together, and also a little bit like
Yeah.
what's the metrics flow approach to this. But before we do that, I want to kind of zoom out again and look a little bit at
Yeah.
like the sort of the who, what, why, when, how, that kind of thing, right? And specifically, I want to talk about like why now, like so you had mentioned, right, that this isn't the first time that sort of semantic layer or semantic concepts has come up, and Juan has a lot of experience with starting companies and seeing the previous waves of this and being a part of some of the new technology efforts around this, particularly in the semantic web. But it seems like very recently now the modern data stack community is very sort of excited and interested in this topic. So why do you think this is happening now?
Yeah. So the what first, like, kind of made me interested in this whole world was I joined Airbnb in 2014, and my job was experimentation, right? So basically what I did was I took assignment data sets, right? Like, I saw button color A, and this person saw button color B, and I need to then go and track a bunch of metrics against those two things and run stats tests to figure out if button color B is better than button color A. And the way that we did that was we basically defined a bunch of metrics, and then we joined them to the assignment data sets, and then produced the analysis kind of automatically. And what we found was that the more different types of questions that we wanted to answer around those metrics, so if I wanted to know, it was Airbnb, so if I want to know how many nights booked happened in like version in the treatment and in the control, then I could go and calculate that. But then I would see that thing moving, and I would want to know, hey, is this happening on Safari or Chrome, or is this happening in this country or this country? Is it happening on this product, like version or this product version? There were all of these different dimensions that I wanted to go and ask questions by. And ultimately what that meant was I now needed to join another data set. And in order to kind of traverse this like graph of different data sets, we had to go from SQL queries to basically defining the join relationships, defining these various dimensions in these underlying data sets so that we could programmatically build all of those joins in order to automate that experimentation analysis. And so I think that kind of goes back to the last question, but the reason why we got to do this was basically two reasons. We had, we had basically hired a bunch of people from Facebook who could manage a Hadoop cluster and keep it up and running to a point where a bunch of data analysts didn't have to think about it. Like, I just had a bunch of compute in the internet and I didn't have to think about it, right? Like, it was just there. And I think that what we have today is that, like, people just use Snowflake and they don't think about it. And it's a bunch of computers in the internet that does, all of the heavy lifting for them. The other reason was we had Airflow. And what Airflow did for us was it took us from writing a bunch of cron jobs, making it so that only data engineers could contribute to data pipelines, to, hey, it's actually pretty easy for data analysts to contribute to data pipelines if we build some kind of, boilerplate templates around Airflow. And so Airbnb had these really easy ways for basically analysts to contribute. We used a bunch of Jinja. In some ways, it kind of looked like what dbt is today, where, you'd kind of have this like mapping of dependencies and you just write SQL and then it would, form a DAG and you would be able to kind of run that and it would be green every day and it would just run. And so what that meant was we had a bunch of compute. We had the ability to go and schedule jobs, which meant that data analysts could go and take a bunch of, core data sets that were being produced, a bunch of raw event logs, all of this kind of stuff, and basically build a bunch of tables and then figure out what to do with them. And I think that the world that we're in today is that we've got great schedulers, we've got dbt, we've got Snowflake, BigQuery, Redshift, a bunch of new data warehouses. We basically have all of these tools that we were playing around with, and kind of interacting at that level at roughly like 2014, 2015 at Airbnb. And so we just got to do a bunch of this stuff ahead of time. And now that's kind of the world that we're in today.
So, so to kind of state this back to you,
Yeah.
So compute is super easy and democratized now. Spin up Snowflake, you're good to go. Whereas a lot more energy had to go into infrastructure management in the past, right? Easy ability to schedule jobs, and not just easy, but sort of democratized. Like analysts can write dbt code and schedule it with a CI/CD scheduler or dbt cloud or whatever they want to use, right?
Yep.
And now they're building a bunch of tables. So basically now
Tons of tables.
Made this easier. People are able to sprawl out. There was the self-service analytics movement. There's like this self-service data pipeline movement going on. Maybe if to
all a
use
part of
a
it.
phrase that I think we're not using, right? And so now, does that mean? I guess maybe it's both of these things. What, it's easier for people to start thinking about how I should work with the semantic layer, and maybe also because it's so easy, there's such an incredible amount of sprawl and duplicate work that's happening right now.
That's exactly it. Basically, it got so easy that everyone, is kind of a part of this process. And what we need is basically a way for a bunch of people to collaborate, right? Like, we need a way for people to centralize a lot of this logic and not just individually define a bunch of pieces of overlapping logic in non-reproducible ways. And at the core, that's kind of what the semantic layer does, right? It's like, it's an abstraction that allows you to go and contain a set of logic and then reuse it across a bunch of different applications, a bunch of different, kind of questions that data analysts would want to ask. So an example is, I ran a ton of experiments on like user growth, right? And every time you add new users, they have, more kind of customer service questions than users who have already been on the platform. And so by adding new users, we generated more customer service tickets. I, to this day, do not know the definition of Airbnb's customer service contact rate, but I know for a fact that a bunch of the experiments I ran lifted that metric and a lot of people really cared about it. and I was in a lot of meetings about like, hey, why is our customer service contact rate going up? And I could go and I could do analysis, but I didn't know the like, various steps to get to that metric. All I knew is that I had a programmatic way to generate that metric at the granularities that I wanted.
So you just said something that I very much agree with. The semantic layer is an abstraction of the logic, so it can be reused by a lot of users. And this is something that I've been talking. I had a whole session with at our summit with Mohammed Asser on knowledge. We called it knowledge layers, and his point is that you need a semantic layer, a knowledge layer, in order to scale. Exactly for this reason, right? You said it before. It's like we really won't have self-service without a semantic layer. So we need a semantic layer to help go scale. Mm-hmm. So now, who's responsible for it? If we're going to get more people, who is responsible? Who is the owner? Who is accountable? Who fixes it when it breaks? Who's getting the requirements?
Yeah.
And how do you manage this centrally, decentralized?
Yeah. I mean, as with all people and like organizational related problems, it's like it depends. It's kind of thing, right? But I think that probably a better answer here is, what I would kind of describe as like what I've seen and what I've seen as, something that works. And that is basically that, you have data engineers and, or, I think at this point, like analytics engineers can do a lot of this work with stuff like Fivetran and DBT, but I need to move data from wherever it is to my centralized data warehouse, right? And I think that that is probably something that, somebody who has a good understanding of how that data is produced and like what formats it needs to be in should be doing, right? They should be able to move it to the data warehouse. They should be able to, do some kind of data transformation on it to make it nice and clean and normalized. Those people are, I think at much smaller companies, it's kind of, end to end. It's the same person who's expected to integrate with like, how do I pull data out of Salesforce all the way through to how do I, talk to a business user about like how the metrics are moving. But I think at, really at kind of like medium-sized companies and up, there are some kind of, barriers that are drawn and people have more specialization. And so I would say typically data engineers are doing that kind of work, maybe analytics engineers in kind of the modern paradigm. And then from there, like the person who is responsible for preparing and like surfacing the data to the end user is the one who should ultimately be responsible for kind of defining the metrics on top of those normalized tables, right? And so typically that would be a data analyst, maybe an analytics engineer, but it's somebody who ultimately has a connection to the end business user and can have a conversation with them about like how should this metric be defined, what are the different caveats, etc.
Aren't we just now starting to throw the word analytics engineer everywhere? And like that's the new thing, and everybody is it. I'm like, I'm calling BS on this thing, truly. I mean, we just put this big label on it, and now we're like, well, you described these three things, and you put analytics engineer in all three of them. And like companies are just this word didn't exist a year ago. So let's take these labels out for now, because I want to really dig into. I really want to dig into like who is doing this work, who is driving the business decisions, who is driving the technical decisions to decide implementing this. All right, and I always say I need to. Where's my T-shirt, Tim, that says "Don't boil the ocean"? Right, because how are we going to avoid boiling the ocean? How are we going to make sure that this doesn't fail? Because I think we all agree that this is a good idea, because we've been saying it for decades. How do we make sure? How do we make sure that we don't fail?
So if you just remove the analytics engineer, I mean, I think that there are basically two personas that are involved in taking data from like where it is to the end business user, and that's the data engineer should prepare all of the data sets into its nice, clean, normalized formats. Ideally, you don't have data engineers just building data marts. Like there is that, in my mind, is boiling the ocean. Like if you're going to try and combine all of your data into nice, clean data marts for every single one of your end business consumers, like good luck. this is,
So,
I mean,
like,
this
these
is,
are the marketing tables. These are the customer success tables. They're like,
yeah,
that's a bad approach.
here's like, here's 180 different marketing tables, and then the marketing team is like, hey, where do I find this data? And you're like, oh, well, it's in one of the 180. How come you didn't find it? Or like, oh, we don't have that metric and dimension everywhere. Let me build 181, tables for you, and like, good luck finding it. That is, in my mind, very problematic. And so, what I would basically suggest is like, you need to basically decentralize this. This kind of has to do with this, like, centralized versus decentralized. You need to build a system that many different stakeholders can contribute to, right? Because like, you've got business stakeholders, you've got technical stakeholders around a company, and they all have different understandings of like different domains of data. And those people should be the ones who are responsible for defining the metrics in their domains. And then they should be able to contribute it back to a system that relies on the same underlying core set of normalized tables that are canonical and true in your organization. And it doesn't matter if many different data analysts around an organization are using the same underlying tables, because that is a set of data that your data engineering team is preparing for the rest of your organization for consumption. But then the data analyst is basically responsible for taking that normalized data and turning it into something that the business user actually cares about.
How in this world, how every time we talk about the semantics, is like, well, you're not going to get one definition of a customer, right? You're going to get so many different definitions of a customer. What's your answer to this? Like, how do we address this with the so many different definitions of a customer?
Yeah, so I mean, this is like really an organizational problem, right? I think that the core of this is like, does your technology enable it, right? And in my mind, the technology that we have right now kind of enables it, because you can just build a bunch of data marts and call a bunch of rows in it, like customer, right? And then everyone just consumes it, and they're like, I'm consuming the customer data, but they're all different customers. And so in my mind, like, one of the values of having structure in this layer is that you can actually define an entity that is a customer, and you can't have two of those. And if you want to be able to like join different data sets together, it has to be the same entity.
But then you're assuming that we will actually agree on what the data for the customer, agreeing what a customer is. And that's, I mean, I agree it's an organizational problem,
Human
but
problem.
but we're not, I mean, then how, I mean,
no, I know what you mean. It's, I mean, gosh, if you could solve that problem.
well, listen,
Like,
I
if
mean,
you could get
well, I mean, my position about this is that if it's a social problem,
yeah,
I mean, there's this great book by Gerald Kane, as a professor in Boston
yeah,
College, called The Technology Fallacy, which is the technology fallacy is that because a problem came out of technology, means that the solution should also be technology.
exactly, yes,
But you just, but, I mean, this is something that we need to agree that I think there
yep,
is not that one single semantic. We have to agree the world has chaos, and we have to embrace that complexity. And if there happens to be different definitions of a customer that we don't agree, then okay, let's just define that. We'll have different versions of, call it customer marketing, call it customer sales, and right, and
exactly,
we know where that comes from. And then you're like, well, in that query that you define your metric, you decide to use the customer marketing table, which may have different rows, but obviously they'll overlap on a lot, but they have
yep,
different. And I know exactly where that metric came from, and then you can explain that.
exactly. So I think that like, I totally agree with your point. Like, technology is partially responsible for this problem, and it's probably going to be partially responsible for the solution. But ultimately, the biggest problem is that you need to get a bunch of people in the room, and to get them all to agree that, like, hey, I'm going to start calling it like a marketing customer, or a, like, I'm going to call it a qualified lead, you're going to call it a like something else, right? Ultimately, there is this people component, but what I'm saying is that technology is still a part of that solution. And I think that technology can build user experiences that basically require people to have those conversations. And so what we do is we basically say, you can't have you can't have two things that are customer that like don't relate to each other in your semantic model. And that's very simple, but it basically means that when you get a marketing person who's entering customer and when you get a product person who's entering a customer, like those two things will not join to each other, and it will basically spit out like a, hey, this relationship is not working. So like y'all need to talk about this. It's a start. It's not like this is not an entire solution to like, organizational problems around data. I wish I had that.
This is a very interesting conversation and debate here to think about sort of what's the right approach to this, how much of it is a technology solve versus a people solve. I definitely like the phrase that you said, Juan, about sort of like the multiple versions of the truth. And I feel like the metrics layer and the semantics layer actually can embrace that pretty well. I guess how do you think, Nick, about reflecting multiple versions of the truth in the semantic and the metrics layer, and in general, how do you approach this iteratively, right? Is there an approach to this where like you pick one entity and it starts off in there, and then you add another, and you pick 5 metrics and then you add a few more? Like, is that the same kind of approach that you would take here as you did take you take with other sort of code projects?
Yeah, I think that's basically right. I think that you want to start with a set of data that like resolves a certain application, right? You want to basically say, hey, the marketing team cares about, these 10 metrics. These are like their 10 primary metrics. These are a bunch more that they care about. And so what might end up happening is that, they define customer in the system. And then when you go and you invite another team to come and collaborate, like there needs to be some resolution there, right? And so I do think that it probably is an iterative process. Like I, the experience that I had at Airbnb, like, it was product teams who adopted this first. Eventually it was finance and marketing and all of these other organizations. And so, I would say that mostly we did not have problems when the other organizations joined, but we did have problems when we did actually have problems when different product teams joined, because actually when I first joined, Airbnb had 3 definitions of what a booking is, which is so problematic for a company that has that as their North Star metric. Like usually, it's like the 5th most important metric that nobody agrees on, not the like North Star one. But I think that, in some ways what this did was it forced a conversation, and it made us realize that like, we need to have different words of like net bookings and, bookings after cancellations, like these kinds of things, right?
Right.
But at
And
the very least, it
yeah.
forces those conversations.
And in some cases those things are layered, right? And it seems like
Yeah.
the metrics layer can support this idea that there's like a booking. Maybe you define a booking, but then you define net booking on top of that, which might be bookings minus canceled bookings minus churn bookings or something like that. And okay, so now
Yeah.
that's net bookings, and these things can actually be built upon each other, right?
Yeah. And like the nice thing about doing this all at the kind of level of normalization, like building this on top of normalized and, these kinds of core data models, is that at the very least, that the underlying data is not duplicative, right? And so if you're going to go and define revenue, and you have 2 different tables that are like different variants of aggregating transactions, and then you're going to go and try and define revenue on top of those, like you might end up with different results just by summing like the, price column in each of those 2 tables. But the problem there is just that you've already done some of the process of defining the denormalization, like defining the aggregation. And so it's kind of, it's not that surprising that you would expect different results. And I think that that's a huge cause of multiple definitions for the same metrics in most organizations. And a lot of semantic layers just are not flexible enough to be able to define metrics on normalized tables.
Yeah.
And I think that that is really problematic.
Now it goes back to what we were saying. I think the dream, which I do think is a measure of success, is that your metrics definition implementation should be literally very, very small. And if you're not accomplishing that, then you're not being successful yet. So I mean, we can't see it just as a dream. Like that needs to be a reality, and that needs to be our North Star when we're thinking about what success looks like when you have a semantics and metrics layer on this. Um, Man,
I totally agree with that.
time flies, and I want to. There's so much stuff.
Yeah.
I do want you to talk. Tell us a little bit about the open source, the metrics flow.
Yeah. So, look, this is the sixth version of like a semantic framework that I've worked on over the last 8 years. And they've all been proprietary, and each one has been each of the first 5 at least has been flawed in some kind of serious way, and I've had all of these learnings and painful experiences trying to kind of expand them and use them in different ways. Some of them I was an end consumer of, and more recently I've been working more directly on them as like a kind of from a product perspective. And I think that what metric flow is it's basically an attempt to solve denormalization. And that sounds like so ambitious and so significant, and like, what does it even mean? But the core of it is that we're trying to build a metrics layer, a semantic layer with a core metrics abstraction on top of the semantic layer that can be defined purely on top of normalized tables. And that being said, we've also built it as like a very flexible framework. So it can be defined on top of raw data sets or denormalized tables, but you basically get more out of it if you have nice clean data and it's not partially aggregated already. But what metric flow is that it is basically a spec for defining the kind of semantic components, right? So the measures, dimensions. We don't actually directly define the kind of, if you think about like a graph, most semantic layers define the edges of that graph as relationships, right? So like, here is the left side of this join and the right side, and let me draw a line between these two tables. We actually define the structures of the tables and the entities that exist within those tables, and whether they're kind of primary or foreign keys. And that allows us to basically have far fewer kind of like points of logic that need to be defined, because we can basically infer all of the potential edges off of each of these data sources. And so there's this spec. You define your data sources, your measures, dimensions, identifiers in those data sources. And then from that, you can basically ask for metrics. And what metric flow does is it takes the semantic information, it takes the request for metrics, and then it compiles that into a SQL query. And what it ends up returning to you is either a SQL query or the result of that SQL query. And so the types of requests that you can make is, I can go and I can define a data source for products. I can go and define a data source for transactions. And then I can go and say, I would like to see, revenue by product type. And under the hood, it says, okay, I have this data source. I have this data source. The revenue metric is defined on top of the transactions table. I know the join relationship. So I can go and basically construct that SQL query. It creates a query plan, and then it optimizes that down into performant and legible SQL. Both of those are super, super important. And then it runs that SQL against the warehouse and returns the result. And you get back, 2 columns, revenue and product category.
All right. So I'm going to summarize this very quickly. As inputs, you take the semantic layer plus the metrics that you want, and then it compiles and it generates some optimized and readable SQL query.
Exactly. And you can do all kinds of stuff on top of that, like ask for, once you really kind of have this data model defined, there are probably, hundreds of dimensions you can ask for each metric. You can ask for any time granularity, et cetera. Like, theoretically, the framework can generate hundreds of lines of SQL for you, and all you have to do is give me revenue by product type, by, store, like square footage, by whatever.
Oh.
So if people want to try this out and get started, what's the best way for them to get their hands dirty?
Yeah, so Metricflow is a GitHub is on GitHub, so you can go there, and that's actually you can go to our website, metricflow.com, and then you'll see it.
Okay.
Um,
Awesome.
you can also just pip install Metricflow, and then it comes with a tutorial with like a fake set of data. So you can just connect it to a data warehouse, and it'll have a data model, have a fake set of data that it'll write. It's like very small data set, but it at least kind of lets you get your hands on it and run it against your own data warehouse.
Oh, that's cool.
All right.
Yeah,
We'll try it out. All right,
please
Nick.
do.
This was we can keep. I got so much stuff I want to go talk about, but we got to go to our lightning round, which is sponsored and presented by Data Art World. Lets us do this fun stuff every Wednesday. So thank you. All right, I'm gonna kick it off. Number one.
Okay.
Will the new wave of analytics engineers be the ones primarily bringing the metrics layer into the organization and the stack, or is it another persona?
I think that the answer is yes, which is a controversial answer based off of this conversation.
Well, all right. Yes. You go next, Tim.
All right. Nick, will the modern data stack be a requirement to take advantage of the latest wave of metric semantic layer, or or for example, can the legacy stack take advantage of this in in the near future?
Yeah, so I think this is like the answer is ideally both. And the reason why we open source metric flow is because we want it to be able to support a wider, set of applications. I think that the core, the like all of the APIs are very generic, right? It's like Python, command line interface. You can write whatever your integrations, you can use it in whatever way you want. But the core there is probably database connectors, right? If you have a variety of different databases that are not, your kind of Snowflake, Redshift, BigQuery, Databricks kind of databases. And those can all be added to the open source project. So please make contributions.
All right. Third, will metrics layer ever become the de facto approach to building your data platform, or is this more like a expert mode or like a cool kids thing?
I think that companies will realize that it's kind of this like there's this paradox of in the early days you don't see it, and then everyone who gets to a certain stage sees it. And so I think that more and more, the people who are later on will see it and then kind of show, people who are earlier on that like, hey, you're building, a bit of a rat's nest right now, and you might want to watch out.
Yeah.
And so my take is that like, I personally think that it should be like one of the first tools that companies buy, and I actually think that it makes more sense at the startup. Like I started working on this after leaving Airbnb and working at a startup and being like, oh my gosh, I need this. My business, partners are asking for so many different cuts of the data, and I don't have time to write every single query for them. So
the modern data stack veterans are they're gonna speak to the younger folks and younger experience wise and say like,
yeah,
don't do what we did.
yeah,
There's a better
basically,
way.
I mean, and like,
And if we can get that
I
information out there, then they'll realize it and adopt it earlier.
yeah, and like I think that's how a lot of technology, ends up evolving. Technology that like impacts larger companies more significantly. That
Yeah.
this is like a trust and productivity problem, and the larger companies experience the trust problem, and the smaller companies are experiencing the productivity problem, and it just gets like more and more profound as you get larger, right? And so
Yeah.
people don't plan for it because they can't foresee it.
This is what I call the balance between efficiency and resilience.
Yeah, exactly.
No, I hope you're right on that, Nick. And I'm hoping also like some of the lighter weight BI tools push us in this direction too, because then people will be like, oh, of course I want to do more in my data warehouse.
Yeah.
Last lightning round question for you. Should data catalogs support the metrics layer as a first class citizen?
Oh, for sure. Okay, so I mean, I feel like we kind of skipped over the relationship to metadata. We got so into like some of the other
It's
conversations,
all
but
good.
um, like so much of the back end of what this is, like metrics are a profoundly important concept within a business. Like it is one of the most stable objects in an organization over time. Like Airbnb was tracking bookings, multiple definitions before I joined, and then still to this day tracks it. And if we had been building up metadata and context annotations of what happened at different moments, like, you know, who the owner is, what the tier is, like whether it's good if it goes up or down, like these are all incredibly important pieces of metadata that we're now tracking on our backend. And we actually expose a GraphQL API for other applications to basically pull that metadata out and surface it. And I mean, I think one of the main differences between, you know, older versions of semantic layers and newer versions is just broad access. And so that's why we expose all of this stuff. Our entire UI can be accessed elsewhere. So
I love your comment that this is such a foundational concept, and actually one of the more stable elements. And I think that's an important takeaway. Like people like there's a purchase, right? And it's like, oh, well, the data to make a purchase was this way at first, but then we had to change it because we're collecting the data different or something like that, or we changed our systems and now it's like this. But the concept of purchase stayed the same, right? So I think that's a really important thing for folks to think about.
That was a very, very important takeaway there. Which, all right, the mesh minute. 1 minute to rant, pontificate, whatever you want about data mesh. Go.
Okay. So I told Juan, I'm like a little anxious about this because I feel like the hardest thing about the data mesh for me is just like really getting my mind around it. And I certainly have opinions and like things that I think are relevant here. But I think that the core of this is that what we're talking about here is trying to define a centralized place that we can manage in a decentralized way, right? A centralized place to define your metrics and expose them as like a clean interface to the rest of the organization. And in my mind, like when I read the data mesh stuff, I think that that's basically a data plane, but I'm not really sure. And I think part of the like hard part about understanding the data mesh is just like real applications, like real examples of how this works. It feels a little philosophical to me still at this point, and that doesn't mean that it's wrong. It just means that like I need more time to understand it. I need somebody to like explain it to me.
Yeah. Valid. It is something. There's a whole book on it now you can go get. So, all right,
yeah, perfect.
But I agree. More case studies would be good. I think hopefully people are trying data mesh and they're going to share their war stories, either successes or failures.
Well, actually, in a couple of weeks, totally. We're going to have Omar from Roche, who's been talking a lot about it, and so eager to learn more about the details on everything.
Yeah,
so
he'll have some good stories there.
All right, Tim, take us away with your takeaways.
All right. So, Nick, you've done such an awesome job helping us to learn about the semantic layer, the metrics layer, and why this is valuable, why this is happening right now. You really referred to and talked about the semantic layer as being sort of this mapping between sort of the data as it exists today, the sort of these tables, to these classes, whether they're orders or products or customers. And the rows are really the individual instances of that class, such as, one of those orders, one of those products. And the idea is to try to create an abstraction so that the logic can be a lot more reusable. And so that way it's a lot more understandable to whether it's the BI tool or the people or whatever needs to ultimately consume that information. And you mentioned about the metrics or the metrics layer being something that kind of is part of that or kind of sits on top of that, which allows you to, to really define your metric in a repeatable way over those different classes or over those different attributes. And to do that in a way that's sort of, I'll just call it smart, right? Whether it's like, if you care about time, then you want to be able to do the kinds of things you should do with time, like, look at it weekly or monthly or, those types of things. So it should be done in kind of a smart way. And this makes a lot of sense. It seems like it's going to really have a profound impact on companies that struggle with, sort of spaghetti code or spaghetti data pipelines, or hey, we implemented Snowflake 4 years ago to replace our crazy monolith, and we just built a new one that's maybe even more expensive in the cloud, right? How do we fix that, right? It seems like the semantic layer and metrics layer can help a lot with that, and why now, right? Well, you mentioned that infrastructure is not as big of an issue anymore. Scheduling and creating these scheduling jobs and creating data pipelines isn't as big of an issue anymore. So now it's much more democratized to build all this stuff out, and so it's becoming faster to create these problems, to create this sprawl. We need to be smarter about how we manage our data pipelines, about how reusable our logic is, and ultimately, I wrote down, we need to lower the bar to be savvy about your data. And I think previously we were thinking more about like lowering the bar to build a dashboard. And I think we all kind of now realize in hindsight that was dumb. Like, it's like, oh, well, just giving people to build a dashboard, obviously that wasn't going to solve becoming data driven, right? You actually need to understand the data. It needs to be semantically meaningful. And I think we're finally having the right conversation about that. So that's my spiel on it. Juan, what are your takeaways?
I got several here. One, I think, remind ourselves the world that we live in today. If you don't have a semantic layer, you're dealing with a bunch of large SQL queries, and on top of all these raw tables, there's too many transformations. You're doing ELT, and managing that is a pain. I think we all agree with that. And truly, self-service without a semantic layer is impossible, because otherwise the users who want to go query that need to have so much technical context, and that's not going to be self-service right there. I like we have a little bit of a disagreement here, but I think I at least came to the same. I ended up agreeing is, I think the dream is to really have the metrics query to be very crisp and concise. And you saying it's a dream, but I'm like, it's a dream that we make it a reality. And if you're not making that real, you're not being successful. I think that should be the North Star right there. I think it's still open the question. We need to help define the ownership responsibility, right? It depends. I mean, that's something that depends on your organization, and that's a lot of the human work, right? If you need to understand who are the people who really understand that data, right? In a smaller company, maybe the same person who does end to end, but this is going to go change a larger company. You do want to have a system where anyone can contribute to metrics, but it's all coming in from that same semantic layer. And you really need to get agreements, get people in the room and have agreements. And I think from a technology perspective, it is interesting to make sure that the technology knows that these two things should not be joined, because that does not make sense to go do that. Start with, this is a very important one. Start with data from a certain application. So you talk to the domain of the marketing team. Well, let's talk about what are their metrics and where is their data coming from, and let them define customer first. And then people get more involved. They're like, well, okay, now we have to go address these issues. Then we can go resolve that. That's a way not to boil the ocean. You have the metrics flow open source. The short answer is you take the semantic layer you built, the metrics, and it will compile it into optimized and readable SQL queries. And finally, should data catalog support the metrics layer as a first-class citizen? Absolutely, yes. Metrics are foundational concept, and I really love this. They're actually the things that are most stable within an organization. And that's a very key takeaway right there. Metrics are going to be there all the time. Let's go treat it with the respect it deserves.
That's right.
Nick, how did we do?
I like that takeaway.
How did we do?
I think we have a t-shirt that we're going to have there, like metrics, respect them, or something like that.
Yeah, exactly. Exactly. I think that they deserve a lot more respect.
All right. Well, back to you, Nick. 2 questions. What's your advice about data, about life, whatever, and who should we invite next?
I'm going to make mine about life. Do I both or just one?
No, both questions.
Oh, okay. Oh, okay. I see.
And about data and life or whatever.
Yeah. I don't know. Be nice to people. Just like, help people out, have empathy, like try to be like open and collaborative in these kinds of conversations. Like, I love that. I love just having these kinds of fun, open conversations. And I think that life is just like a lot more fun when you're like nice to people and you like, try to relate to people. So I appreciate. Yeah.
Word.
And let's see next. I don't know. Like, I think if you want to, I think that there are some people who've really thought a lot about this metric stuff. There's Aaron Keyes was somebody who was at Airbnb and spent a lot of time thinking about this, and he's now at Slack. Johan Rydberg is at Spotify and has been thinking a lot about this space. These are people who, like, in my mind, have been thinking about this for a long, long time and have formed, quite polished and tested opinions in like large organizations. So I would say if you want to learn more about this space and really talk to practitioners who are like building this stuff right now, those are great examples.
All right.
That's a great idea.
We'll be reaching out. Well, all right. Next week, we're talking about knowledge graphs at the Knowledge Graph Conference. I will be there, and we're going to have another. So I'll be in New York next week with Francois Scharf, who is the general chair of the Knowledge Graph Conference, talking about all the stuff that's going over at that conference. And with that, Nick, thank you so much. And as always, thanks Data Art World who lets us do this fun. Cheers, Nick. Thank you so much for this awesome conversation.
Thanks so much.